In this guide, why OAuth 2 alone can't prove who the user is, how the ID token carries identity claims as a signed JWT, what the 5 mandatory validation checks are, and when to use the UserInfo endpoint versus the ID token directly. Identity Expert, powering you to be an expert in identity. Today we're unpacking OIDC OpenID Connect. Every time you click Sign in with Google, continue with GitHub, or log in with Apple, you're using OIDC. It's the most widely deployed identity protocol on the internet, and it answers a question that OAuth 2 deliberately left unanswered. Not what can this app access? That's OAuth's job, but who is the user? OIDC adds a second token on top of OAuth 2's access token. The ID token, a signed JWT that carries your identity, verified by the identity provider. Any application can validate it without calling the server again. By the end of this video, you'll know exactly what makes an ID token trustworthy, how to validate one, and where the real risks are in production deployments. Let's make OIDC concrete before we look at any code. Think of OAuth 2 as a valet parking service. You hand the valet a claim ticket, a scope token that says, "This ticket lets you park and retrieve my car." The valet can use that ticket to move your vehicle. But the ticket doesn't say who you are, it says what they're permitted to do. Now imagine the hotel front desk prints you a second card alongside the valet ticket, a signed identity card with your name, a photo, and an expiry date. Any hotel employee, any application can look at that card and know who you are without calling the front desk. The valet ticket is OAuth 2's access token. One grants resource access, the other proves identity. They travel together in the token response, but they are fundamentally different things, and confusing them is the source of most OIDC security bugs. OAuth 2 RFC 6749 was designed for authorization, not authentication. An access token says, "This client is permitted to call this API." It deliberately says nothing about who the human behind the request is, whether they're still active or what their attributes are. Before OIDC, every identity provider invented its own solution. Facebook had the Graph API's Me endpoint. Twitter had its own user endpoint. Google had its own profile schema. Each had a different JSON shape, different claims, and a different authentication mechanism. If you wanted federated login across multiple providers, you wrote a separate integration for everyone. OIDC, published in 2014 by the OpenID Foundation, standardizes identity on top of OAuth 2. One protocol, one token format, one discovery mechanism, and any conforming application can authenticate users from any conforming provider, without custom code per vendor. OIDC works by adding one magic ingredient to the standard OAuth 2 authorization code flow, the OpenID scope. When a client includes OpenID in its scope request, it's signaling, "I don't just want resource access, I also want proof of who this user is." The flow looks exactly like OAuth 2. The client redirects the user to the OpenID provider with the OpenID scope, a nonce, a random value the client generates and will verify later, and a PKCE challenge for public clients. The user authenticates and consents. The provider redirects back with an authorization code. The client exchanges that code at the token endpoint. But instead of only an access token, the response now includes an ID token, a signed JWT from the provider. The client validates the signature using the provider's public key, fetched from the JWKS URI in the discovery document. Then it validates 5 claims. The issuer matches the expected provider, the audience equals the client ID, the token hasn't expired, the issued at time is recent, and the nonce matches what it sent. All 5 must pass. If they do, the user is authenticated. Here's what this actually looks like on the wire. The authorization request is a get-to/authorize with the standard OAuth parameters, but scope includes OpenID, profile, and email, and a nonce parameter carries the random value. PKCE parameters travel alongside for public clients. The token exchange is a standard back-channel post. The response JSON carries 3 fields that matter: access token for calling the UserInfo endpoint, optional refresh token, and ID token. The 3-part base64 encoded JWT string. Decode the middle section of that JWT and you get the ID token payload. The critical claims is the issuer URL must match the provider's discovery document. Sub the stable permanent user identifier unique within the provider. Odd audience must equal your client ID exactly. Exp expiry in Unix seconds I at issued at, and nonce the random value you sent in the request. The optional UserInfo endpoint returns additional attributes: name, email, picture, locale, keyed to the same sub. Call it with the access token when you need claims too large for the ID token itself. The most critical risk in OIDC is ID token forgery or replay. A relying party that skips signature verification, accepts the alg:"none algorithm, fails to validate issuer, audience, expiry, or nonce, or treats a UserInfo response as authentication proof, has no identity guarantee at all. Any attacker who intercepts an ID token can replay it at another relying party that accepts the same issuer, which is exactly why validating auth strictly is non-negotiable. The mix-up attack, documented in RFC 9207, targets deployments with multiple identity providers. The attacker tricks the relying party into sending an authorization code from one provider to another provider's token endpoint, leaking the code entirely. The mitigation is the IS response parameter in the authorization response. The relying party pins the expected issuer before the redirect and verifies it matches the code that comes back. Two other critical rules. Never use an ID token as an API access token, the audience validation breaks and the trust chain collapses. And never treat OIDC's authentication ceremony as sufficient without validating every claim independently in your own code every time. As of 2026, OIDC is the foundation for some of the most ambitious identity infrastructure being built. OpenID Federation 1 replaces bilateral trust agreements, where you manually configure each identity provider, with cryptographically signed trust chains managed by Federation authorities, enabling large-scale multilateral federations like EIDAS2 and the Research and Education Network EduGain. FAPI 2, the OpenID Foundation's financial-grade security profile, tightens OIDC with mandatory PAR, sender-constrained tokens via DPoP or MTLS, and removal of legacy response types. Open banking deployments across Europe, Australia, and Brazil are all migrating to FAPI 2. Most significantly, the EU Digital Identity Wallet mandated by EIDAS2 reframes OIDC around user-held verifiable credentials. Instead of Google or Okta issuing an ID token about you, your own wallet issues attestations directly to relying parties. Member states are required to offer EUDI wallets by end of 2026. The Shared Signals Framework, CAEP and RISC, is closing the long-standing gap where a revoked account at the provider kept working at every relying party until the ID token expired. Next on Identity Expert, Passkeys, the web authn standard that replaces passwords entirely. Subscribe so you don't miss it. All primary sources cited in today's guide are listed on screen. You'll find direct links to the RFCs and specifications in the video description below. If this breakdown helped you understand the topic better, please subscribe to Identity Expert. We publish a new protocol deep dive every week. Thanks for watching. If there's a specific identity standard, authentication flow, or security protocol you'd like us to cover next, drop it in the comments below. We build our content based on what the community asks for. Subscribe and hit the bell so you never miss an episode.